Surface chemistry. We have studied different types of chemical reactions that occurs in nature and the reactions which we perform in laboratory under closed and isolated system. Right. So now we will learn about the surface phenomena. What is surface chemistry? How the things stick to the matter, how the matter absorbs the liquid, how gases stick to the surface of any matter. So these are some questions which arises in the mind of people, that why this thing happened, why you put what happened when you put cloth in the water bucket. What happened? It absorbs the water. So what is that phenomenon? So the things which or the chemical reactions that occurs at the surface, that is surface chemistry. And the basic phenomena is absorption. So in this chapter, we will learn two types of phenomena, absorption and adsorption. So the accumulation of the molecular species at the surface rather than in the bulk or interference of the solid or liquid is termed as adsorption. Alright, let me show you how this thing happens. In surface chemistry, all the reactions takes place at surface. Okay, so you can just term this as the branch of chemistry that deals with the phenomena that just exert on the surface or interference. Okay, so it just happened between the two bulk surfaces, right? So for example, there are two phases, that is the solid phase and the gaseous phase. So we have two different phases here, and these two different phases just stick together. Gas do not penetrate inside that much solid surface. So what happened is just stick to the surface. Gaseous phase and solid phase. So like this, we have so many examples. As if you put some hard substance or the stone, what happened? That stone just dip down or sink in the water, but the water do not penetrate in the solid. So what happened? It's just absorbed on the surface. If we take some two liquid phases, if I take oil and water, what happened? The two phases do not mix with each other, but still they are in the same container. The surfaces are attached. If I put oil drops on water, what happened? They just stick to that surface, but it do not mix, does not penetrate to the bulk. It is a surface phenomenon. If we take liquid and gas example, all right. So these are the example. These are the bulk phases, which shows the process of absorption. Okay. There are different types of examples which we used to see in our daily life, and that are the examples of absorption. First is dissolution. See, you can see the powder do not mixed with the water. Okay. Second is the crystallization. This is also a surface phenomenon. Corrosion. You can see the orange color film, brown color film over the piece of iron rod. You generally see this thing. So this is also a surface phenomenon. That is the example of absorption. Second is heterogeneous catalyst. Heterogeneous catalyst is like if you put catalyst in any reaction, it do not mix with that. Catalyst process is like lock and key mechanism, and if catalyst is different quality, it do not mix with that reaction. It do not it do not participate in that reaction properly. So that is a heterogeneous catalyst is also an example of adsorption. Electrode process. Electrode process is electroplating. You have studied in 8th class the process of electroplating. What happened? We used to deposit the copper on another plate. That is also a surface phenomena. The copper do not penetrate on that metal rod on which you are electroplating. It's just stick to the surface only. Alright? So the molecular species or substances which concentrate or accumulate at the surface is termed as exudant. And the material on which on the surface of which the adsorption takes place is known as adsorbent. So what is the difference? The thing which is depositing or concentrating on the surface, that is exhibit, and on which the adsorption process takes place, that is the adsorbent. I think these things are clear to you all. Okay. So let's just talk about the actions of adsorption. So I'm going to tell you different types of examples where the adsorption takes place. First is, if a gas like O2, H2, CO, carbon monoxide, chlorine, NH3, SO2 is taken in a vessel containing charcoal powder, it is observed that the pressure of gas in an enclosed vessel is decreased. The gas molecules concentrate at the surface of the charcoal, gases are adsorbed in the surface. So, for example, I think in 10th class for the purification by of metals, you have studied about the property of charcoal. Charcoal have the property to adsorb the things. Okay, so if you just performing any reaction and you put charcoal over there, so what happened, that those gases will deposit on that charcoal, and that led to decrease in the concentration of the gases. So this shows the adsorption process. They will not go inside that charcoal, the bulk of the charcoal, but they will stick to the surface of the charcoal. All right. Second, in a solution of organic dye, say methyl blue, when animal charcoal is added in the solution and is well shaken, it is observed that the filtrate turn colorless. The molecules of dyes thus accumulate on the surface of the charcoal are adsorbent. So if you put the charcoal in the methyl blue, means dyes, so dyes get absorbed on the surface of the charcoal and the entire solution become transparent, or you can say colorless. See, this is the example. I just put charcoal inside the gas chamber. So as you can see, the gases molecules deposit on the surface of charcoal. And if I take liquid and over the gas phase is there, you can see the gases molecules adsorb on the surface of that liquid. In both the cases, adsorption is there, but it does not move to the bulk. It does not penetrate. It's just gases molecules just stick to the surface of the adsorbent, whether it is charcoal and whether it is water. Let me just show you how this thing happens. The substance on which the adsorption takes place is adsorbent, and the particles of gases which adsorb, that is known as adsorbate. All right, so the charcoal in this reaction is adsorbent and the gases molecules are known as adsorbate. Okay. Now, aqueous solution of raw sugar when passed over a bed of animal charcoal become colorless as the coloring substance are absorbed by the charcoal. The same reactions takes place. The charcoal absorbs the color substance and the entire solution will become colorless. The air become dry in the presence of silica gel because the water molecules get absorbed on the surface of silica gel. In some reactions, we require dry gas if I want to perform a reaction. In absence of water molecules, then I have to enclose the system, and to remove the water molecules from the gas, I use silica gel. I just put silica gel in the chamber that absorbs the entire water from the gas. Okay, air become dry in the presence of silica gel because the water molecules just absorb over the surface of that gel. Now, this adsorption can be reversed because this is a surface phenomenon and you can easily remove the adsorbent and the adsorbate. How? That process of removing the adsorbed substances from the surface on which it is absorbed, that is known as desorption. At that time, the molecules will start leaving the surface of the adsorbent. This thing happens in one case. First is when we increase the temperature. And second one is when we reduce the pressure. For example, if I increase the heat or temperature, the desorption will take place. The kinetic energy of the molecules increases and they will leave the charcoal surface. And second is reducing pressure. If I reduce the pressure, what happens? The gaseous molecules will start leaving the surface of the charcoal and desorption process takes place. Alright? This is how the desorption happens, by increasing the heat or reducing the pressure. So heat and pressure play an important role in the process of desorption and as well as the adsorption. Difference between adsorption and absorption. In adsorption, the substance is concentrated only at the surface and does not penetrate through the surface to the bulk of the exhibit, while in absorption the substance is uniformly distributed throughout the bulk of the solid. As you can see here, the molecules are just adsorbed on the surface of the exhibit. Okay, but what happened in absorption, the molecules just penetrate inside the molecule, the matter, and uniformly distributed. This is how the adsorption and absorption differs. Adsorption is surface phenomenon, and absorption, the things get absorbed to the bulk and uniformly distributed inside it. In one word, if you want to distinguish between the adsorption and absorption, so adsorption is the surface phenomenon, but the absorption is the bulk phenomenon because the particles just distribute uniformly inside the bulk. If we put a chalk inside the ink, what happens? The ink will just stick to the surface first. But if we leave it for a long time, it's just penetrate. So if you see, if I put this piece inside the ink, what happened is just stick to the surface only. It is not inside the bulb. So this is the adsorption. But if we move inside it, so what happened? It will move uniformly. I put it for a short period of time. At that time, only adsorption takes place. But if I put that chalk inside the ink for long time, what happened? It will distribute like this, as you can see in this video. It will just absorb in the bulk uniformly. That is the difference between adsorption and absorption. All right. A distinction can be made between adsorption and absorption by taking an example of water vapor. The water vapor are absorbed by the silica gel, absorbed by the calcium chloride and absorbed by the silica gel. If we put calcium chloride and silica gel in a chamber, then what happens? So this is the air, and we just put the silica gel in the air chamber. So what happened? The water molecules from the atmosphere or from the chamber just start sticking on the surface of the silica gel. This is the adsorption process. All right, the molecules from the air get adsorbed. But what happened in the absorption? If I take calcium chloride in silica gel and put it in a chamber, what happened? It absorbs the water that present there, and that make it soft. Earlier it was a powder like substance, but now when water get absorbed inside it, it becomes soft. So in silica gel, what happened? The water get into the spaces between the molecules, but in adsorption in silica gel is just a stick to the surface. So when it's happened in the surface, it is adsorption, but when it move, that is absorption. Okay. In other words, in absorption, the concentration of adsorbate increase only at the surface of the adsorbent, while in absorption, the concentration is uniformly throughout the bulk of the solid. Just now I've explained you this thing. Both adsorption and absorption can take place simultaneously also, and that at that time, that the term that is used where both the reactions take place at the same time, that is sorption, and it actually describes both the process. So there are so many things that happen where where the adsorption and absorption takes place simultaneously. And this is the example of sorption. Sometimes what happens, the molecules get stick to the surface first, and they will also penetrate inside the molecules. So as you can see, first the molecules get stick to the surface. At this time, this is known as surface adsorption, and this is exorbitant. And when it moves inside the bulb, and that is known as absorption. So what happened, the process at which both the processes takes place at once, that is known as sorption. Mechanism of adsorption. Inside the adsorbent, all the force acting between the particles are mutually balanced, but on the surface, the particles are not surrounded by atoms or molecules of their kind on all sides. Hence, they possess unbalanced and residual attractive force. These forces of the adsorbent are responsible for the attractive adsorbent particles on the surface. The extent of adsorption increase with the increase of the surface by unit mass of the adsorbent at a given temperature and pressure. So you can see when the molecules combine. Okay, if we talk about the adsorbent, the molecules inside are attracted by the force of attraction. But the upper molecule is attracted by the side and lower molecules, but the upper side is actually vacant, and the attractive force is present there. So what happened? When the things come closer to that, it gets stick. That is how when we dip a plastic ball in the water gets stick, but it will not penetrate inside the plastic water ball or bottle, but it gets stick to the surface because of the attractive force present there. All right, and the extent of its absorption increase. This increase with the increase of surface area by unit mass of the adsorbent at a given temperature and pressure. I've already told you temperature and pressure plays an important role in this. So another important factor featuring adsorption is the heat of adsorption. In previous chapters, we have studied about heat of fusion, heat of fission, different types of heats are there. Now we will talk about the heat of adsorption. So during adsorption, there is always decrease in residual force of the surface, and that there is decrease in the surface energy which appears as heat. So that is why when heat decreases there, it means the heat is losing. That shows that this is exothermic process. So adsorption therefore is invariably an exothermic process. In other words, delta H of adsorption is always negative. When a gas is adsorbed, the freedom of movement of its molecule become restricted. This amount to decrease in the entropy of the gas after adsorption will be delta S. If what happened, the gaseous molecule when stick to the surface of the adsorbent, what happened? Their randomness decreases. All right, their randomness decreases, and simultaneously their entropy decreases, and so the delta S will be negative. So for absorption, delta H is negative, and as well as delta S is negative, which simultaneously affects the Gibbs energy. So adsorption is thus accompanied by decrease in enthalpy as well as in entropy of the system. For a process to be spontaneous, the thermodynamic requirement is that at constant temperature and pressure, delta G must be negative. That is, there is decrease in energy. So on the basis of equation, delta H is equal to delta G is equal to delta H minus T delta S. This is the Gibbs free energy equation. So delta G can be negative if delta H has sufficiently high negative value as minus T delta S is positive. Thus, in an adsorption process, which is spontaneous. A combination of these two factors makes the delta G negative. If if delta H is high, what happens? It will just simultaneously in negatives the value of delta G. So as the adsorption process, the delta H become less and less and negative. Ultimately, delta H becomes equal to T delta S, and at that time the delta G becomes zero. That shows that the reaction is in equilibrium state. It means that the delta G will be zero. When the change in Gibbs energy is zero, it means that reaction is at equilibrium state. Okay.